Hello everyone, in this video we're going to be looking at section 10.1, starting with subsection 2, which is ellipses. So again, maybe we're familiar with ellipses, maybe we're not, but we have an interesting definition here. So an ellipse is the set of all points x, y, the sum of whose distances from two distinct fixed points called foci is a constant. Right? So in other words, I've got a focus here and a focus here. So I have, that's why they're called foci, because there are two of them. Right? And then this distance here plus D1 plus D2 is the same as if I took this distance here plus this distance here. The sum of this distance plus this distance is the exact same as the sum of this distance plus this distance. And then if I did it again, if I had this point right here, then this distance right here plus this distance right here is the same as the sum of those distances, right? And so that's where this formula, this definition comes from. Okay, so the line through the foci that intersects the line through the foci intersects the ellipses at 2 points called the vertices, right? So the vertices are those points that are on the actual ellipse. Right, and it is where they're on the same line that the focus is on, or the foci are on. Right, the chord that joins the vertices is the major axis. Right, so essentially, what the major axis is always going to be the longer part of an ellipse, right? Because an ellipse could either be like an egg-shaped vertically or an egg-shaped horizontally. Right now it looks like an egg-shaped like horizontally, right? And so the major vertex can either be vertical or horizontal. In this case, it's horizontal. The center is always going to be the guy in the middle. Just the center is what we normally think of a center as. And then the other axis, the smaller axis, is going to be the minor axis, right? Okay, so the standard form of an equation of ellipse with center HK, major axis of length 2a. So in other words, this is the major axis. This length is 2a. So a is the distance from the vertex to the center. And then I have a minor axis of length 2b. So that's the distance from here. From here to here, right? That's 2b, and then that means that this distance right here, do it over on this side, is b, right? So that is, in general, a is always going to be the bigger value because a is always going to be what I multiply by 2 to get the full length of the ellipse, right? So what this is saying is this is the equation, right? It's x minus h squared over a squared plus y minus k squared over b squared equals to 1. Or, and this is the case when I have a major axis is horizontal. So in other words, that's what we have up here, right? If the major axis is vertical, that's when I have an ellipse that looks like that, right? And how do you know the difference? Well, remember, a is always going to be the bigger term, right? A is always going to be the 2a is always going to be the length of the major axis. So in other words, if the denominator of the x term is bigger, then I know that it's going to be a horizontal guy like this. And if the denominator of the y is bigger, then I know it's going to be a vertical ellipse, right? The foci lie on the major axis c units from the center, where c squared is equal to a squared minus b squared. So this distance right here from the, if I can put it in there, maybe I'll put it over on this side, there's less stuff going on. The distance from the center, so that's this distance right here, is going to be c. the distance from the foci and the center is c squared is equal to a squared plus b squared. So once I find what a and b are, then I will be able to find what c is, and therefore I'll be able to find where the foci are. Okay, and then there's this other term called the eccentricity. It's basically just how like round it is, and that is going to be the ratio of c over a, right? C being what we call it, a being also what we call it. Okay, so now the question is, we have this equation. We know that it's going to be either at this point an ellipse or a hyperbola because it has an x and a y squared in it. But obviously, since we're asking this question in the ellipse section, it's going to be an ellipse. And we're going to have to put it in standard form, and then we're going to have to determine the center, vertices, foci, and eccentricity. Okay. So first things first, we're going to need to write it in standard form. So I've got an x squared and an x, a y squared and a y. So in order to get it to look like x minus something squared plus y minus something squared, I know that I am going to have to complete the square actually twice, right? Complete the square with the x terms and complete the square with the y terms, right? So I'm going to go ahead and collect the x terms together. So I write 4x squared minus 8x plus y squared plus 4y, and then I'm just going to bring the 8 over to the other side. Okay, so now I'm going to, in order to complete the square, remember the coefficient of x squared has to be 1, so I'm going to pull out a 4 here, so I'm left with x squared minus 2x, and then plus y squared plus 4y. I don't need to factor anything out. And then now I complete the square with this term and this term, right? So 4 hangs out for the ride, and now I do half of the b term. So half of negative 2 is negative 1 squared is plus 1. All right, so I get x squared minus 2x plus 1 minus 1, because I have to balance it, so maybe I'll put those in different colors. Right, so I know to add 1, but if I add 1, I know I need to also subtract 1. And now with the y squared term, I get y squared plus 4y, and then I take half of 4, which is 2, and square it. So I know I need to add 2 and also subtract 2 to keep it balanced. Right? So now I need to get rid of this pesky negative 1, but in order to do that, I have to distribute the I have to distribute the 4. So 4x squared minus 2x plus 1, and then if I distributed that 4 to that last term, I get minus 4 plus, and then I would get, I'm just going to put parentheses around the y squared plus 4y plus 2, just to remember that those two guys are grouped together. Or I'm sorry, those three terms are grouped together because that's what I'm going to use to complete the square. Right? So now this is a complete square and this is a complete square. Right? So 4 times, now remember it's x and then plus the middle term divided by 2. So the middle term is negative 2, so I divide that by 2, I get negative 1. So x minus 1 quantity squared minus 4. Well, actually, yeah, I'll just leave it there. Plus, and then I would do the middle term, which is 4, divided by 2, which is 2. So I get y plus 2 quantity squared minus 2 is equal to 8. So 4x minus 1 squared. And now if I add 4 and add 2 to the other side, I would get 14. Right, which why is that not what I want? Oh, sorry, because I did the wrong thing here. I should have, sorry guys. When I divided 4 by 2, and then I squared 2, which gives me 4. So this should have been plus 4 minus 4. Apologize about that. So this would be plus 4 minus 4. And then this should be minus 4 here. right? So now I get 16, which looks better because that's something squared, right? Okay, then finally, to put it in standard form, remember I need to have 1 right as my on the right side of my equal sign. So I need to divide everything by 16. So if I divide everything by 16, I'm left with x minus 1 squared over top of 4 plus y plus 2 squared over 16 is equal to 1. So now I am in standard form. Okay, so now we got to talk about what everybody is, right? The hardest thing to figure out in this case to me is to think about what A and B are. So A is going to be whatever squared makes the biggest denominator, right? So since 4 squared makes 16, that means A has to be equal to 4, right? And then whatever the smallest guy squared is, that makes the denominator, whatever makes the smallest denominator squared is B. So in this case, B is 2 because 2 squared is 4. So what does that mean? That means that the smaller denominator goes with X. Remember, if the smaller denominator goes with X, right, B is the smaller guy, then that means I have a major axis vertical. So if my major axis is vertical, that means that my ellipse looks like this, right? I'm going to draw a little bit better. My ellipse looks like that. Okay, and yeah, now I can identify my center, right? My center, whatever I'm subtracting from X is my H, and whatever I'm subtracting from Y is my K, right? So H is equal to 1 because I'm subtracting 1, and K is equal to minus 2 because that's what I subtract to get plus 2, y plus 2 there. All right, so my center, which is HK, is going to be 1, negative 2. All right, so that was the first question, is what's the center? There's that guy. So now the vertices. How do I find the vertices? I find the vertices by taking, I know the distance from the center to the vertex or the vertices is A, right? So in this instance, if I had, I'll draw my oval a little bit bigger here, my ellipse a little bit bigger, right? I know that this distance, whoops, I'll draw it green, from the top to the bottom is 2A, which in this case is 8, right? So that means this distance here from the center to the top or the bottom, in other words, from the center to the vertices, is going to be 4, right? So what do I do in order to get the vertices? I do, the y value stays the same as the center, but then I'm going to take the x value stays the same as the center, but I'm going to take the y value, which is k, and I'm going to subtract 4 and add 4. And that will give me where my vertices are, right? So here I would take 1, negative 2 plus 4 would be 2, and then 1, and then I would subtract 4, which would give me negative 6. Right? So those are going to be my vertices. So now I want to find the foci. How do I find the foci? Well, remember when we drew this picture, the foci is c units from the center, right? So if my foci are like right here, and this distance right here is c units from the center, right? So first I need to find c. So remember, c squared is equal to a squared minus b squared. So what is a squared is going to be 16 minus b squared, which is 4. So this is going to give me 12. And then when I take, that means that c is equal to, when I take the square root, it would be 2 radical 3. Right? The square root of 12 is 2 radical 3. So in order to get my foci, what do? Again, I take my center, and the h value is going to stay the same, but now I'm going to take the y value and add or subtract c. All right? So in other words, I end up getting 1 and then 2 plus, sorry, it's negative 2. Negative 2 plus 2 radical 3. And then it would be 1, and then it would be negative 2 minus 2 radical 3. So that would be my foci. Move that down a little bit so it's not on top of that. Okay, and then finally, eccentricity. So my eccentricity is just the ratio of E is C over A. Two C's in it? Yeah. So remember, it's just E equals C over A. So in this case, C is 2 radical 3. A is 4. So I end up getting radical 3 over 2 is my eccentricity. Right? So if I were going to sketch this, right, I know my center is at 1, negative 2. So here's 1. We'll say this is negative 2. So this is my center. And then negative 6. I go all the way down to negative 6. 2, 3, 4, 5, 6. 1, negative 6 is my other vertice. And then 1, positive 2 is my other one here. So again, this is a rough sketch because we didn't do any work to figure out how wide this is. But this would be kind of what my ellipse would look like. All right, these are my vertice, and this is my vertice. And, or I guess we'd call that a vertex. This is a vertex, and then this is my center. All right, just kind of a rough sketch of what that would look like. Okay, so in the next video, we will look at hyperbolas.